Equations of lines. There's two lines we're looking for. We want the line tangent and we want the line that's normal to the graph of x squared plus y squared equals 25 at the point 3, -4. Okay, first off, I'd like us to get in the habit of just confirming that the point we're interested in is actually on the graph. If this point's not on the graph, then there's no point in going any further because we can't find a normal line or a tangent line to a point when that point's not even on the graph at all. So let's just double check. If we put in x equals 3 and y equals -4, 3 squared is 9, -4 squared, squaring the negative makes it positive and it becomes positive 16. Add those together. Yes, we really do get 25, so we are okay. This point is on the graph. Now, we got to find the tangent line. Once you have the tangent line, the normal line's real easy. So let's go with the tangent line because we're pros at that. In order to find the equation of a line, we need two things. We need a point that we know is on the line, and we need the slope of that line. Okay, the point already taken care of. We know we want to go through this point. 3, -4. The slope, in order to find the slope, that's going to be dy dx. The change in y over change in x, hey, that is slope. And we're talking about the instantaneous change, so that's dy dx, that's our derivative of y with respect to x. So okay, let's find dy dx. Unfortunately, our equation is not written in y equals form. It's not explicit. It's an implicit relationship between these two. So we can't just take the derivative and walk away. We have to use implicit differentiation. But this one's not bad. We're going to take the derivative of the entire equation, one term at a time. The derivative of x squared is 2x, and then we lower the exponent by 1. It was a 2, it becomes a 1. So I'm not even going to bother writing it. The derivative of y squared, well, if it was an x squared, it would be 2x. So for a y squared, it's 2y, but then don't forget, we need to put the dy dx on that. If you haven't watched the video for number 6 yet, you may want to go back and see that to understand why that dy dx pops up there. We discussed it in class, but you may want to go through that discussion on the other video. Equals the derivative of 25 is 0. One of the most common mistakes I see on implicit differentiation problems is we take the derivative of this and get 2x, the derivative of this, we get 2y dy dx, and then we forget that this derivative becomes a 0 and we keep it as 25. We'd have a 25 there instead of a 0, and that's going to throw everything off. So make sure that you remember even constant terms we're taking the derivative of, and the constant terms become 0. Okay, our goal is to solve for dy dx. So first thing we would do would be to subtract the 2x over to the other side, and then divide by 2y. Well, that minus sign is going to be there. When we divide by 2, that 2 is going to cancel. We still have an x, and we're going to divide by y. And so our derivative for any point is -x over y. Well, the slope we're interested in for our line is the slope evaluated at the point, 3, -4. So that's going to be negative x over y. X is 3, y is negative 4. Our negative signs cancel out and become positive. So dy dx at this point is 3/4. Well, now that we've got the point and the slope, we can write the tangent line. The tangent line will be y minus the y-coordinate, y minus negative 4 is our y-coordinate. So y minus negative 4 equals the slope, dy dx was 3/4, times x minus the x-coordinate of our point, 3. And of course, you probably are writing y plus 4 instead of y minus negative 4. Same thing, no difference. The normal line looks exactly the same, with one difference. Still goes through the same point, so we keep the same x and y, but the slope is the opposite reciprocal. So instead of a positive 3/4, it should be a negative 4/3. All right, well, that's the end of the problem, but just so that we can see it here, it's probably worth looking at the graph so we can kind of verify that that really is the tangent line. So let's look at the graph. We're looking for the graph of x squared plus y squared equals 25. Do you know what that graph looks like? Of course you do. You're so smart and good looking. X squared plus y squared equals 25 is a circle centered at the origin. There it is. It's a circle centered at the origin. The radius of that, 5, because it's x squared plus y squared equals the radius squared. So radius of 5. And then the point 3, negative 4 is right down there. All right. In order to see our line, let's add another line to this. And we're going to graph the tangent line here and see if it looks like it's a good tangent line at that point. So y minus negative 4 equals 3/4 x minus 3. Graph that. Oh, look at that. Isn't that beautiful? It's a nice tangent line, goes right through our point, and you can really kind of see that slope is just perfect. For the heck of it, let's throw our normal line in there too so that we can see how that looks. So same equation, y minus negative 4 equals, but the slope is the negative reciprocal. Let's get our tangent line on there it is. Not our tangent line, our normal line. Y minus negative 4 equals negative 4/3 times the quantity x minus 3. And there's our normal line. Tangent line, normal line, they couldn't look more perpendicular. Go through the right point. Everything's all happy.